Good morning. Today let us study about determination of solubility by using conductance measurement. Application of conductance measurement to determine the solubility and the solubility product of sparingly soluble salt, especially solubility and solubility product of sparingly soluble salt. We have seen in the previous class what are sparingly soluble salts, what are freely soluble salts, etc. Okay, how it is determined from conductance. Okay, for sparingly soluble salts, remember, for sparingly soluble salts, the determination of solubility is very difficult. Solubilities cannot be determined by chemical methods. For sparingly soluble salts, the solubility product cannot be determined or difficult to determine by chemical method. Why? Why? Because if you add a pinch of silver chloride, it is a sparingly soluble salt. Only the concentration of Ag plus and Cl minus are very less because of very poor solubility. Due to poor solubility, the concentration of soluble ions Ag plus and Cl minus ions are very less. Therefore, the chemical methods cannot be used to determine the solubilities of sparingly soluble salt. However, such extreme small solubilities, such extreme small concentrations of ions can be determined by conductance method. Okay. Now we will see the procedure. What are the steps involved in determining the conductance of sparingly soluble salt? For example, silver chloride in water. Silver chloride, determination of solubility and solubility product of silver chloride in water. Okay. The salt, let us take the silver chloride salt. The salt is repeatedly washed with water. It is repeatedly washed again and again with water to remove the soluble ionic impurities. For example, along with the silver chloride, there may be sodium chloride impurities. So the salt is washed again and again with water to remove the soluble ionic impurities. Next step, a small pinch of the washed silver chloride is placed in the water. Okay, is added into water or suspended in water at 25 degrees Celsius. On adding a pinch of silver chloride into water, it forms an equilibrium. It forms a silver chloride is soluble in very small quantity to give Ag plus and silver minus ions, and the ions, the soluble ions and the undissolved salt are equilibrium with each other. We have studied in the previous class. Okay. Using thermostat, the temperature is maintained. See, using thermostat, the temperature is maintained at 25 degrees Celsius or 30 degrees Celsius or 35 degrees Celsius. Okay, in the third step, place the conductivity cell. The conductivity cell is placed into the saturated silver chloride solution. Okay. The conductance of saturated silver chloride solution and pure water, the conductivity or conductance of the saturated silver chloride solution and also pure water are measured. Therefore, the conductance of silver chloride solution, the conductivity of the silver chloride solution, silver chloride alone can be calculated from subtracting from water. Okay. Now we know the conductance. We have measured the conductance of the saturated silver chloride solution. Using the formula, we can calculate the solubility of the sparingly soluble salt silver chloride. The resistance of silver chloride solution is equal to rho into L by A. The rho is the specific resistivity, L by A is called cell constant. On taking inverse, in the 1 by R equal to conductance. Therefore, 1 by rho equal to specific conductance. This is specific resistance 1 by rho equal to kappa, specific conductance or conductivity. Therefore, C into cell constant equal to kappa. Okay, there are two formulas. Remember, there are two formulas used to calculate the solubility or concentration of the silver chloride that is dissolved in water. How much silver chloride is dissolved in water? That is solubility. That is concentration of silver chloride. Okay. Now lambda m, the molar conductance, from the molar conductance it is determined. How the molar conductance? There are two formulas. This is the formula 1000 lambda m, molar conductance of silver chloride solution equal to 1000 kappa by C. This formula is used when C is expressed in moles per liter. Remember, this formula is used when the concentration is expressed in moles per liter. Kappa by C, concentration of soluble silver chloride. Okay, this formula, that is kappa by S moles per meter cube. This formula is used when concentration is expressed in moles per meter cube. Now, here the specific conductance is the conductance of 1 meter cube of the solution. 1 meter cube, length, breadth, height, 1 meter. Here, kappa is the specific conductance is the conductance of 1 centimeter cube of the electrolytic solution. Okay, therefore length, breadth, height 1 centimeter into 1 centimeter into 1 centimeter. Okay, so when you are given problem, you please see what is the unit. For example, in this problem it is given meter. Therefore, and this lambda naught is given in Siemens meter square unit. So what which formula you need to use depending upon the units. Okay, you carefully look at the units. Therefore, on interchanging, okay, you will get S equal to kappa by lambda m. Now, lambda m equal to lambda naught AgCl. What is lambda naught AgCl? We have seen earlier. Lambda naught AgCl is molar conductance or equivalent conductance at infinite dilution. See here, the salt is sparingly soluble salt is only slightly soluble. The salt is only slightly soluble. Therefore, it is like very dilute solution. Very dilute solution because only very few Ag plus and Cl minus ions are present. Therefore, lambda molar conductance of AgCl solution is equal to lambda naught, the molar conductance at infinite dilution or in limiting concentration or in zero concentration. Okay, lambda naught AgCl is obtained from the for weak electrolyte. For weak electrolyte, Kohlrausch's law is used. Kohlrausch's law is used to calculate the lambda naught AgCl. Okay, so it is given here lambda naught Ag plus. You sum up the conductance of Ag plus and Cl minus to give 138.26 into 10 power minus 4 Siemens meter square. You see, mole per mole. Okay. Now in general, this is for univalent ions. AX/By is in equilibrium with the y minus, y plus, and YB x minus lambda naught AX/By equal to x lambda naught AY plus y lambda naught Bx minus. Let us see a problem to understand the unit. What is the formula to be used? Okay, the specific conductance of silver chloride solution and water for 2.68 into 10 power minus 4 and 0.86 into 10 power minus 4 Siemens per meter. Okay, you see the unit is given in meter, not in centimeter. If it is given in centimeter, you need to use this formula. It is given in meter. And also this is again given in meter. Now you see the solubility, calculate the solubility in moles per liter, but they asked in moles per liter. Okay. Now the specific conductance of solution is equal to specific conductivity of silver chloride solution plus water, because silver chloride, a pinch of silver chloride is soluble in is added to water. Therefore, water, the ions present in water also contribute to conductivity, conductance. Therefore, copper AgCl plus copper water, therefore copper AgCl only due to silver and chloride ion, that is equal to 2.68 minus 0.86 into 10 power minus 4. Water is a poor conductor. Water is a poor conductor because it is only partially dissociated to give H plus and OH minus ion. Okay, now on substituting the formula S equal to copper by lambda naught AgCl. Lambda naught AgCl is calculated from Couldra's law. It is given in this formula in meter square. Therefore, this is also in meter. This is also in. So you put this and lambda naught AgCl, and you will get the value on cancelling the unit also. Solubility equal 1.32 into 10 power minus 2 mole per meter cube. See, this is mole per meter cube. You will get on cancelling the unit, you will get mole per meter cube. But they have asked to calculate the solubility in moles per meter, mole per decimeter cube. How it is calculated? 1 meter, the unit conversion is very, very important now. 1 meter equal to 10 decimeter. Therefore, 1 meter cube equal to 10 power minus 3 decimeter cube, decimeter whole cube. Therefore, you substitute 1 meter cube equal to 10 power minus 3 mole per liter or mole per decimeter cube. Therefore, 1.32 into 10 power minus 5. Okay. So, for sparingly soluble salt, the concentration of Ag plus and silver minus ions are very, very less. Therefore, the chemical methods cannot be used. Only conductance methods can be used very readily. So you please say what are the steps involved? What is the formula to be used? You might be mindful of units. What is the unit they have given in, for example, in some textbook they have given in centimeter, Siemens per centimeter copper, and this is Siemens per meter. Okay, so please be careful when you solve problems with the units. Otherwise, you will be able to solve very easily. Thank you for watching.